Hi, Algebra 2 class, God bless you. This is actually our first Friday. Thank God for Friday. And so I hope you're getting the hang of all this, and please just keep working through with me and we'll get through this and it'll be great. Okay, so here we are on Friday, summing up in a sequence form summing the sequence terms up into a series, now for geometric series. So this is 12.5 geometric series starting in your book on page 544. Now, in order to sum the first n geometric sequence terms, we have a new equation. All we need is the first term, s sub n is the first term a1, parentheses 1 minus the multiplying factor r to the n power, how many terms we want, over 1 minus r. And if you want to see how we got that formula, if you care, see page 544 for the derivation. Okay, let's learn how to plug into this for example 1. Find s sub 10 for the geometric sequence 5, 15 halves, 45 fourths. Now, as you can see above there, it's hard to take the second one divided by the first one, but if I can look and see what I need, it's 5 times 3 halves is 15 halves, and 15 halves, the second term, times 3 halves gives me 45 fourths. So I can see my multiplying term r is 3 halves or 1.5 for the calculator, and my first term is 5. So now in order to do S10 on the calculator, I'm going to need to do it like this for the first time. So do it just the way I'm showing you here, parentheses 5, parentheses 1 minus 1.5 power 10 divided by parentheses 1 minus 1.5 close parentheses. So you have to follow all the parentheses. You can't skip anything. And when you do, you get 566.65. Make sure you can get that on the calculator. Okay, for my example 2, find A3 for a geometric sequence with r equals 2 and the sum of the first 6 is 189. So the way we'll go about this is we'll use that information given us for the sum of the 6 geometric sequence terms is the sum of the first times 1 minus r 2 to the 6th over 1 minus 2. So plugging in for S6, we can put in 189 is equal to A1, 1 minus 2 to the 6th on your calculator. 2 power 6 is 64 over 1 minus 2. And this gives us 189 is A1, negative 63 over negative 1, or just positive 63. And then A1 is 189 over 63. So now having the first term, we can go back and use our formula that we did before to be the nth term for geometric sequence is A1 times n minus 1 times r, r to the n minus 1 power. So simply put, A3 is the first term 3 plus 3 minus 1 or 2 2's. So 3 times 2 squared is 12, and that's how we get a to the third sequence term. Now for example 3, we're going to do this. Charity should like this one. This is about money. The arithmetic sequence for d equals 1, if the caddy on a golf course gets $1 for the first hole, 2 for the second, and up to 18 for the 18th hole, we have an arithmetic sequence that we can say S18 is n over 2, 18 over 2, 1 plus 18, or 9 times 19, $171, which would be pretty good for a caddy. But if we use the geometric sequence of r equals 2 and just get a penny for the first hole, 2 pennies for the second hole, but a penny times 2 to the 18th for the 18th hole, now look what we do. This is how we have to do it on the calculator. S18 is 0.01, the first term, in parentheses, 1 minus 2 power 18, divide parentheses 1 minus 2, and you should be able to get 2621.43. Make sure you can get it. Now this next is the future value of an annuity, which your parents might know about investing in, but this is mostly a plug into the formula and learning how to use the calculator. So over here, what we're going to actually plug into is the second one, FV is future value, is equal to the amount you're putting in monthly, 1 plus the interest rate to the n power minus 1 over the interest rate. Okay, so here we'll plug into that formula on example 4. Determine the value after 40 years of a $75 monthly annuity paying 4.8% APR compounded monthly. Okay, so first, for 40 years, the number of months is 40 times 12, or 480 months. That's going to be our n. Now the interest rate is 4.8% per year, which is 4.8 divided by 100, or 0.048, divided by 12 to get the monthly interest rate, which will be 0.004. So now plugging in, and this is all we needed to do, future value in 40 years is the $75 monthly payment, 1 plus 0.004 power, 480 months minus 1, divided by the monthly interest rate, 0.004, just like this on the calculator, and you should get the big number, 108,654.10, okay? So that was mostly a plug-in. Now the sum of an infinite series that keeps on going forever with the multiplying factor must be less than 1 though. If it's not, it'll blow up and just go to infinity. So this is S1, or S infinity rather, that's a misprint. S infinity should be A1 over 1 minus R. Now remember, our S sub n for the first n terms was just like this, but it had an extra 1 minus R to the n on top, which is taken off for the infinite terms. So example 5, determine whether the infinite series converges, meaning come to a finite number, or diverges, blows up to infinity. So our first infinite sequence is 1 minus a half plus 1/4 minus 1/8 plus ... forever. So 1 times negative 1/2 is negative 1/2. Negative 1/2 times negative 1/2 is negative 1/4. So we can see that R equals negative 1/2. And S is simply 1 minus 1 divided by parentheses 1 minus negative, or plus 1 plus 1 divide 2. And so that gives us 1 divided by 3/2, or the reciprocal of 3/2, 2/3. So an infinite sequence, amazingly enough, of those terms that go on forever, each multiplied by negative 1/2, all sum up to 2/3. Now if we look at part B, we see that we're summing from k equals 1 to infinity the sequence terms 2 times 3 to the k. Here our multiplying factor is 3, but since R is greater than the 1 that we need it to be to converge, the series diverges, or means it blows up to infinity. Okay, so for the homework, we want to find S sub 10 for the sequence starting out as 5 plus 15 plus 45, because they've given us A equals 5, R equals 3. So the second term is 5 plus 3 is 15. The third term is 15 times 3 is 45. Now watch how we do this, just exactly this way in the calculator. Hope you're getting used to this. S sub 10 is the first term 5, parentheses 1 minus the R, 3, power 10, close parentheses, divide 1 minus 3, and that will come up to the big number, 147,260. Now for problem 4, S sub 9 is equal for the sequence, geometric sequence 64 minus 32 plus 16 on for 9 terms. Well, if we look at 64 times negative a half, we see that we get negative 32, and negative 32 times negative 1/2 will come out to plus 16. So we can see that that's what our R is negative 1/2, and our first term is 64. So using our formula, S9, sum of the first 9, is 64. Now this has to be just like this exactly on the calculator with the parentheses. 1 minus, parentheses, 1 minus, left parentheses, negative 0.5, right parentheses, power 5, right parentheses, divided by, parentheses, 1 minus negative, or plus 0.5. And now make sure you can get this to come out to 42.75. It has to be exactly like it's shown, typed into the calculator. For problem 6, we have S25, the first 25 terms added up with the geometric sequence 3 plus 1 plus 1/3 plus dot dot dot. First term is clearly 3, and the R multiplying factor is clearly 1/3. 3 times 1/3 is 1. So this is how we have to do this one on the calculator. S25 is 3 parentheses, 1 minus, again, left parentheses, 1 minus, divide 3, right parentheses, it must be like that, power 25, divided by, left parentheses, 1 minus 1 divide 3, right parentheses, and make sure you can come out with 4.5. For problem 8, we get this alternating 1 series of 1 minus 1 plus 1 minus 1 on forever. But since R is equal to 1 and our limitation for converging was the absolute value of R has to be less than 1, well, the absolute value of -1 is 1, which is not less than 1. So this sequence diverges, meaning it blows up. Now looking at the sigma notation for 10, k equals 1 to infinity of 2/3 to the k. So our s to the infinity is a1 over 1 minus r. So our a1 is 2/3 to the 1, or 2/3. Our r is also the term in parentheses 2/3 to the k, so r is 2/3, a1 is 2/3. So the way we do this is just like this, 2 divide 3 in parentheses, divided by 1 minus 2 divide 3, which is really 2/3 over 1/3, or 2. Okay? Now for 12, we have k equals 1 to infinity, 2 over 3 to the k, which is 2 over 3 to the 1, 2/3, plus 2 over 9, 2 over 3 squared, plus 2 over 3 to the third, 2 over 27. So you can see that multiplying by 1/3, 2/3 times 1/3 is 2/9 the second term. 2/9 times 1/3 is 2/27 the third term. So clearly the first term is 2/3 and the multiplying factor is 1/3. So again, this is how we do it. The first term, 2/3 in parentheses, divide in parentheses 1 minus 2 divide 3, which is really 2/3 divided by, just this should come out to 1, okay? See if you can get that to come out to 1. So for 14, S11, if we know that A1 is 3 and R is 4, then we can say that A2 is 3 times 4, or 12, and A3 is 12 times 4, or 48. So using our and sum formula, the first 11 terms add up to 3 parentheses 1 minus 4 power 11, divide in parentheses 1 minus 4, which is the huge 4,194,303. Make sure you can get that. Now for 16, we have S31 we want to find. For the sequences, geometric sequence 8 plus 1 minus 6. Now to find the D, I can take 1 minus 8, the second minus the first, because this is an arithmetic sequence, and that's minus 7. And if I take the last minus the second, minus 6 minus 1 is also minus 7, giving us a clear D equals minus 7, and an A1 equals 8. Now this is going back to what we did in the last lesson yesterday. So S of 31 is n over 2, 31 over 2, 2 times the first term, 2 times 8, plus 31 minus 1 times negative 7. Or 31 over 2 times 16 minus 30 plus 30 times negative 7, which is minus 210, or 31 divide 2, parentheses 16 minus 210. For 18, we want to find, using sigma notation, the sum of the first 12 terms from k equals 1 to 12 of the sequence term, 4 times 1/2 to the k. Now we have to put k equals 1 to figure out what A1 is, which is 4 times 1/2 to the 1 power, or 4 times 1/2 equals 2. But clearly the multiplying factor is 1/2. So here using our formula, S12 is equal to parentheses 1 minus 0.5 power 12 divide parentheses 1 minus 0.5, and to 3 places, that should come out to 3.999. Now for 20, we want to sum from k equal 1 to 10, the first 10 terms of the sequence term 2 times negative 3 to the k. Now using k equals 1, the first term is 2 times negative 3 to the 1, or negative 6, and the r is what's in the parentheses, negative 3. So here for S10, we take the first term, negative 6, times exactly like this. Now 1 parentheses 1 minus left parentheses negative 3 right parentheses power 10. The negative has to be in parentheses. Divided by parentheses 1 minus negative 3, or 1 plus 3. So make sure you can get that to come out to 88,572. And for 22, we want to find S8 if a sub 1 equals 32 and a sub 6 equals 1. So we're going to have to do this in steps. So a sub 6 is equal to a1 times r to the power 6 minus 1, which we covered as how to generate geometric sequence terms. So plugging in for a6 equals negative 1, a1 is 32, r to the 6 minus 1 is r to the 5th. Dividing both sides by 32, we have r to the 5th is negative 1 to the 32. Now, the only way to do this on the calculator is left parentheses, negative 1 divided by 32, right parentheses, power, left parentheses, 1 divide 5, right parentheses. And your calculator should say negative 0.5, which of course is negative 1/2. Now you have to do it just like that. So now we can get what we wanted. S8 is 32a1, again, left parentheses, 1 minus the negative in parentheses, negative, left parentheses, negative 0.5, right parentheses, power 8 divided by parentheses 1 minus negative, or 1 plus 1 divide 2. Make sure you can come out to 21.25. For 24, we want to find S12 if A3 equals 5 and A6 equals negative 40. We're going to have to take a few steps on this one too. So we're going to use the general sequence term where a sub n equals a sub k, any term, times r to the n minus k power. So plugging in what we know, it's a sub 6 is equal to a sub 3 times r to the 6 minus 3. We know that a sub 6 is negative 40. A sub 3 is 5 times r to the 6 minus 3 is r to the 3rd. So dividing both sides by 5, we get r to the 3rd is negative 40 over 5, or negative 8. Now to get the final answer, we need to put negative 8 in parentheses, as shown, power in parentheses 1/3, and r comes out as negative 2. Okay? Now in order to finish this one, we need to find out what a1 is. So we're going to have to go back into the generator function. A sub 3 is equal to a sub 1, negative 2 to the 3 minus 1, or 5 equals a1 times 4, or dividing a1 equals 5/4. And 5/4 is like 5/4 or 1.25 for use in the formula. So S12, where 5/4 is 1.25, the first term, is 1.25 again, parentheses 1 minus parentheses negative 2 parentheses power 12, divided by parentheses 1 minus negative 2, 1 plus 2, comes out as negative 1706.25. Make sure you can get that. For the last one, we're going to do S infinity if S3 equals 208, S4 equals 204, and S5 equals 205. And again, remembering that S5 minus S4 leaves just A5, and so we can subtract 205 minus 204 is 1 for A5, and A4 is S4 minus S3 like we did on the previous problem. So that would be 204 minus 208 is negative 4. So looking at what we have A4 is negative 4, A5 is 1. So the multiplying factor is always the next one divided by the last one, which we would see as 1 over -4, -1/4. So again, we're going to have to work backwards on this. The opposite of multiplying by -1/4 is multiplying backwards by -4. So A3 is -4 times -4 plus 16. A2 is 16 times -4 on your calculator, or -64. And A1, what we need, is -64 times -4, or 256. So our A1 that we had to have was 256. So remember, our S infinity is the A1 divided by 1 minus R. So here we have 256 divided by parentheses, 1 minus negative or plus 1 divided 4. Make sure it comes out to 204.8. And thank you. This is the end of the week. We made it. God bless you all. Stay healthy and safe, and I'm praying for you.